Okay, welcome to Chapter 3. In Chapter 3, we are going to be taking a look at some applications of derivatives. So we're going to be looking at velocity and acceleration. You may have talked about that in physics class. And then we're also going to talk about optimizing equations or functions and some applications of that. In this first lesson, I'm actually borrowing the lesson from the University of Waterloo. So all my examples come from this video lesson that they've created. You can go to their website and check that out. They also have lessons that correspond to a lot of sections in our textbook. This one happens to correspond really nicely with section 3.1. Be careful when you go through their material. A lot of times they go further than we would normally go in high school. All right, so in the first part of the lesson, we're going to talk about something called the second derivative. So in chapter 2, we were only ever taking the first derivative, and today we're going to learn about what's the second derivative. Well, the second derivative is just when I take the derivative of the derivative. So I'm just taking the derivative twice is basically what's going to happen. Now remember that the derivative tells me the instantaneous rate of change of the function at any x value. And so what I'm doing when I take the derivative twice is I'm finding the rate of change, the IROC, of the rate of change. So the first derivative usually just tells me how quickly something is changing, and now we're going to find out the speed of that change. In function notation, normally for the first derivative we used f prime of x, now we're going to use f double prime of x. And in Leibniz notation, instead of dy dx, we say d squared because we're going to take the derivative twice. And it's going to be in terms of x both times, so we square the x. Another way to write this is to say I'll take the first derivative, dy dx, and then I'll take the derivative of that. So I'm taking the derivative of the derivative. All right, so let's get started with an example. I've got an equation here. It's just a nice power equation. I'm going to rewrite it. So it's still f at x, but I can rewrite this so that I don't have that root x at the end. And then I'm going to take the first derivative on my way to finding the second derivative. So just taking the first derivative, just like last chapter, I bring the 4 down and subtract 1 from the exponent. And then I'll bring the 2 down, multiply it with the 3, and subtract 1 from the exponent. And then same thing here at the end, bringing the half down, multiplying it with the 5, and subtract 1 from the exponent. Now, if the question had asked me to find the first and the second derivative, then I would simplify the first derivative because they're asking me to actually find it properly. But this question is only interested in the second derivative, so I'm not going to simplify. I prefer the exponent in this form because it's easy to take the derivative of. And now I'm going to find the second derivative. So making sure that you've got the label correct on each line, which one are you looking at? And now I'm just taking the derivative of the derivative that we already found. So bringing the 3 down, multiplying it with the 4, subtract 1 from the exponent. Derivative of 6x is just 6, and then I'm going to bring the negative 1/2 out and multiply it with negative 5/2. So I get 5/4, and subtracting 1 from the exponent, I get negative 3/2. And then I'm just going to clean this up. So the negative exponent comes down, and the root it's a square root because 2 is in the denominator, and x cubed, the cubing can go on the inside or the outside. Don't forget to extend your fraction bars over your whole denominator. All right, in example 2, we're going to find the second derivative is what it says. Find the second derivative given that y is equal to this. Now, this equation is something with x's divided by something with x's. So this is a quotient rule. I've got like my f over my g. And remember that the quotient rule tells me to take the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So we're going to go through all those steps. That's just for the first derivative. So dy dx is the first derivative. Taking the derivative of the top, that's just 5 times the bottom. And then we'll subtract. So I've done these first two bits. I'm moving on to the subtraction. This time I'm going to leave the numerator alone and take the derivative of the denominator. And then we'll divide. We're going to square that denominator. Remember that you're squaring the whole denominator, not just the x. You're also going to square the coefficient. So before I take the second derivative, it's in my best interest to clean this up a little bit. This is a mess for me to take the derivative of, and I'm kind of hoping that some nice things happen here. So I'm going to multiply 5 times 2x, and then I'm going to multiply the negative and the 2 into this bracket at the same time. So it's a negative 2 times positive 5x, that gives me negative 10x. And then it's negative 2 times negative 3, that gives me positive 6. And then on the bottom, I'm squaring the 2 and squaring the x. All right, now this cleans up nicely. I get rid of the 10s in the numerator, and I'm just left with 6. And then, sorry, the 4 is still there. And then I want to take the derivative of this. So I'm going to clean it up and bring the x actually upstairs. So it becomes x to the negative 2. And then at the same time, I'm going to just reduce this. 6 over 4 is the same as 3/2. And so you could write the you could write the whole thing over 2. So somebody else might write this. That's just as correct. These things are the same. I'm going to go ahead with this one here. It's slightly easier sometimes for you guys to take the derivative when you view that 2 as a coefficient. So pulling it out front, look at it as a coefficient. It's not a quotient rule, right? Because there's no x's in the denominator. So this one's a nice, easy one to take the derivative of. Now I'm taking the second derivative. So taking the derivative twice, and it was in terms of x both times. I'm going to bring the negative 2 down and multiply it. I'm just going to write that out in case you're not sure where I'm coming up with this. And then I'm going to subtract 1 from the exponent. And then I'll simplify. The 2's cancel. I'm left with negative 3, and x to the negative 3, that's going to go down to the denominator and become x cubed. All right. And just like last time, if this question had said find the first derivative and the second derivative, then I would have simplified this line here and brought that x down to the denominator as well. But because it only asked for the second denominator, I didn't simplify the first. All right, example 3, we're going to find, again, this says find the second derivative if f at x equals this. And now what we've got here is the power of a function, or the chain rule, because we've got the power of 7 as the outer function, and then we've got this polynomial as the inner function. So when I take the derivative here, I'll bring the 7 out front, leave the inner function, leave the baby inside, and then subtract 1 from the outer function exponent. Now that I've taken the derivative of the mama and left the baby inside, I'll take the derivative of the baby, or take the derivative of the inner function. So just looking at that bracket inside, I don't care about the 7 anymore, I've already dealt with it. I'll take the derivative of this as 12x squared plus 6x. Okay, now I can go right into finding the second derivative from here, but I'm just going to take out, there's a common factor of 6 in this last bracket. I'm going to take it out just to make the numbers smaller when I'm taking the second derivative. So when I pull that common factor of 6 out, it comes to the front and it gets multiplied with the 7. So 6 times 7 is 42. Oops. And I'm dividing by 6 here. Now you might look at that and say, like, well, why didn't she take the x too? Because there is a common factor of x here. So I want you to imagine that I pulled the x out here. Well, then I would have something with x's times something with x's times something with x's, and I have a triple product rule. That's actually grosser to take the derivative of. So I don't want to do that here. I want to leave it as just one thing with x's times one thing with x's. All right, so taking the second derivative then. Remember that when I have this coefficient out in front, it's just a constant multiple. So sometimes we forget about this rule. The rule tells me I can just leave the 42 out front and take the derivative of the inner bit. Okay, so I don't need to worry about that derivative. I'm actually going to move this over because just looking ahead, I see that this is going to be a big derivative because it's a product rule with a chain rule inside of it. Okay, so I'm thinking about the product rule. So I'm imagining this is my first function and this is my second function. We've already used f here, so when I write the shorthand, I'm going to call it u prime. So this is going to be my u times v plus u times v prime. So this is going to be my v. And you wouldn't normally write those things in green. It's just to show you my thinking. So I'm going to take the derivative of that first thing here. Now the first thing is a chain rule, so I have to bring the 6 out front, leave the baby inside, leave that inner function alone, subtract 1 from the exponent, and then take the derivative of the inner bracket. So the derivative of that inner bracket is 12x squared plus 6x. Okay, that is just u prime, this thing here. Ooh. So that's a lot of work just for that first step. We still need to multiply it by v. So I still need to tack this bracket on the end. And then we'll add. Now I'm going to leave the first thing alone, so I'm leaving the u alone. And then I'm going to multiply by the derivative of v. So this one's a little bit simpler. I'm just going to take the derivative of each part. Okay, so this is my v, this is my u, and this is my v prime. And again, normally I wouldn't write this stuff with the green. All right, so now you see, like, we really like that this 42 is out here. I don't want it all mixed in here and have to pull it out as a common factor afterwards. Leave it out. In order to try to simplify this, I'm going to look for common factors because remember, to simplify, I want it factored. So I'm looking through first for some coefficients. This guy has a coefficient of 6, but I don't see any, and I'm splitting at the plus sign, right? When I'm looking at the first thing plus the second thing. There's no coefficient here for me to take a look at, so I'm not going to pull out the 6. Now, the next thing I notice is that I've got 4x cubed plus 6 or plus 3x squared, and I've got it over here repeating. So there's definitely a common factor of that. Other than that, there's no bracket here that matches this bracket over here. So I'm kind of stuck. So for that bracket that matched, there's 5 of them here and 6 of them here, so I can pull out at least 5 from both. And when I pull out 5, they're going to be gone from here. There's going to be 1 of them left over here though, right? There were 6 and I divided away 5 of them. Okay. So, trying to simplify this, I don't see any anything else in common here. So what I'm going to do is, I do see, sorry, I'm just looking at my notes and I did it in a different way, but we're on the right track here. Okay, so what I'm going to do in the bracket here, there's nothing in common for me to common factor out, so I actually have to expand this all out and try to refactor it. Hopefully some stuff will just cancel away and we won't have to do like a difficult factoring, because there's still quite a bit of stuff in there. Okay, so I'm going to leave the 6 out front and I'm just going to multiply these 2 brackets together. So I'm going to have 12x squared times 2x squared. And then I'm going to have 12x squared times x. So that's going to give me 12x cubed. And then over here, I'm going to have 6x times 2x squared. That's going to give me another 12 cubed. So that's going to give me overall 24x cubed. And then I can multiply the 6x times the x. And then over here, I'm going to do the same thing. I'm going to multiply these two brackets together. So first, oh, I don't need the brackets anymore. So I'm going to get 16x to the 4. And then I'm going to get 4x cubed. And then here, when I multiply these guys together, I'm going to get 12x cubed. So 4x cubed plus 12x cubed, that gives me 16x cubed. Now I'm skipping that step, right? Like I'm multiplying them together and collecting like terms at the same time. If that's too much, take the time and write out that step. And then the last term is the 3x squared times 1. All right, so I'm going to multiply the 6 in here, and so what I get then is 144 x to the 4th plus 144 x cubed plus 36x squared, and then everything else is just tagging along. And now I'm going to collect like terms in that last bracket. The simplification on this one's a bit of a drag. So we've got 160x4 all right, now we want to try and factor this last bracket. So hopefully you see here that I've got an x squared that I can pull out of all of them. When I look at the numbers though, there's no number that I can divide out of all three. So I'm going to pull out an x squared. I'm going to write it at the front. Normally when we have like an x with an addition or subtraction factor, we just put it at the front with the coefficient. And then in the bracket, I'm left with just a quadratic. And you'll check if this one factors. This one does not, so we're going to stop there and we're all done. Remember when I marked this kind of question, even though this looks like a lot of work here, most of the marks are here. So we're talking like sometimes 5 or 6 marks in that first line, depending on how many product rule, quotient rule, chain rules there are, and like 1 or 2 marks for all of this work. So it looks like a lot, but remember that really the calculus is on the top line, or on this line here as well, right? This is where the 2 bulk of the marks are. All right, the next thing we're going to talk about is velocity and acceleration. I'm going to pause the video here and start a new one.